Hello, and you are welcome to Safety Talk with Adiat. On Safety Talk with Adiat today, we are going to be looking at a very important topic, an overview of HSE in the petroleum industry and the hazard of H₂S in the petroleum industry. So the topic is more or less a two-in-one kind of a topic, and this particular topic was given to me by the Nigeria Association of Petroleum Explorationists, University of Ibadan Student Chapter, under their able president, Mr. Edefizent, and the organizer of the program, who happens to be the Secretary General, Mr. Ogini Victor. This topic have been delivered on a webinar to these students, and I decided to make another video to enable my subscribers to enjoy this training. It is more of a training than just a mere safety talk. So please come along with me as I will treat this topic in details. All personnel working in an H₂S classified area must be trained on the hazards and safeguards associated with hydrogen sulfide gas. Meanwhile, because of the two-in-one nature of the topic that I'll be treating today, I am going to briefly talk about the HSE in the petroleum industry before I proceed to talking about the hazard of H₂S in the petroleum industry. Although H₂S is not limited to the petroleum industry alone, but I want you to know as a fact that H₂S is an acid which is sometimes present in natural gas and crude oil, and is perhaps the most dangerous toxic gas encountered in the field of petroleum operation. Some of the other industrial activities that can produce H₂S gas include pulp and paper manufacturing, rayon textile production, chemical manufacturing, wastewater treatment plants, and coke ovens. Hydrogen sulfide can also exist as a liquid compressed gas. Now, this H₂S training will cover a minimum the following topics. Number one, I'll be talking about the properties of H₂S. Then I will talk about H₂S detection methods and protective equipment. Then I will talk about the health effects of H₂S exposure. Then I will talk about the personnel protection against H₂S exposure. Then corrosion effects. And finally, I will talk about the contingency planning and how to rescue somebody that is being knocked down by H₂S. That is where I'll be talking about first aid and possibly the CPR and things like that. Please come along with me. So the first things I will be talking about is HSE management system. HSE management system. What is HSE? HSE is an acronym for Health, Safety and Environment. So when we say HSE management system, it's a comprehensive framework that is used by organizations in preventing, mitigating and eliminating disruptions and losses caused by workplace accidents, risk and hazard exposures, and environmental phenomena. So further to this, an HSE management system is also key to monitoring an organization's compliance with relevant laws and standards. Okay, there are some key words in what I just said there are three keywords which have been shedding more light on it, which will bring better understanding to what we are talking about about the HSE management system. The first one is accidents. The second one is risk, and the last but not the least is hazard. So I will explain in details what these keywords meant, and this will give better understanding to what we meant, or what we are after, or what we are driving at when we say HSE management system. Okay, there is another keyword, we call it near miss. I will explain that one also briefly. So please come along with me. So in order to shed more light into the understanding of HSE management system, I said I'm going to be explaining some keywords like accidents, risk, and hazard. Okay, now I will start by incident. An incident is anything that has the potentiality to cause injury or damage. Okay, but when an incident happened and that incident leads to destruction or injury or damage to reputation of the company and so on and so forth, that is referred to as an accident. But when an incident occurred but it does not cause any damage, there is no loss, there is no injury, that is described as a near miss. So please try to understand the distinction between the two. An incident could be an accident, and an incident can also be a near miss. So an accident in a nutshell is an unwanted occurrence caused by unsafe act and unsafe conditions, which result in injury or damage. Now, the next one I want to explain is risk. Risk is a function of the probability of occurrence of an undesired event. What is an undesired event? Accident. Together with a measure of its adverse consequences. So that is risk. So in mathematical terms, we can say risk is equal to probability times consequences. Okay? Now, the next one is hazard. Hazard is defined as the potential to cause harm. So anything that has the potentiality of causing harm, ill health or injury, damage to property, damage to plant, damage to product or the environment, production losses, or increased liability are known as hazard. So when we understand all these terminologies, then we will understand what HSE management stands for. Because what is our focus? Our focus is to prevent accidents. Our focus is to avoid risk, and our focus is to eliminate hazards. So if you want to eliminate hazards, you have to first of all identify the hazard. It is only when you are able to identify the hazard that you can remove them or you eliminate them. Okay, but if you are not able to remove or eliminate, then the next thing is to control those hazards. So once you are able to control the hazards and you are able to avoid risk, then you can prevent accident. That is the bottom line. Okay, and if you are not able to do all these things, that means you have failed in the HSE management system. Okay, and once an accident happened, there are two consequences. There is what we call the direct and the indirect consequences of accident. Okay, so that is the cost, direct cost and indirect cost, and this will be applied to the company, to the individual that sustained or that the accident happens to, and the nation as a whole. So it is very, very important for companies and for organizations to adopt HSE management system in order to prevent accident, in order to avoid risk, and in order to control or eliminate hazards. Since we are going to be looking at the HSE in the petroleum industry, so I think it will be important or reasonable for me to mention what do we mean by petroleum industry. The petroleum industry, which is also known as the oil industry or the oil patch, includes the global processes of exploration, extraction, refining, transportation, and marketing of petroleum products. Okay, the largest volume products of the industry are fuel oil and gasoline, and that is the more reason why another way of calling a petroleum industry is, you can hear people saying petroleum industry or oil and gas industry. It is the same thing. Come along with me. Let me now go straight to the properties of H₂S. H₂S, as I said earlier on, is an acid, which is sometimes present in natural gas and crude oil, and is perhaps the most dangerous toxic gas encountered in the field of petroleum operations. Now, what is its chemical name? The chemical name for H₂S is hydrogen sulfide, while the formula is H₂S. The color, it has no color. It's a colorless gas. Okay. The odor, does it have smell? Yes and no. Yes, because at a very low level, we have something like rotten egg odor. So that is the distinctive rotten egg odor. That is when H₂S is at low level. But at high level, there is no smell. Why? Because the H₂S itself is going to deaden your sense of smelling. The olfactory lobe will be blocked. Okay? So, and that is the more reason why we cannot rely on our sense of smelling to detect H₂S. It's not the best. Boiling point. What is the boiling point of H₂S? The boiling point of H₂S is minus 60 degree or minus 76 degree Fahrenheit. Minus 60 degree centigrade or minus 76 degree Fahrenheit. What is the vapor density with respect to air? The vapor density of H₂S with respect to air is 1.189. Okay, and auto ignition temperature, that is at what temperature will H₂S get auto ignited? That is 260 degrees centigrade or 500 degree Fahrenheit. So whenever H₂S is exposed to temperature, when it reaches 260 degrees centigrade, it will catch fire. It will get auto ignited. Okay. Then what is the flammable limit? The flammable limit is 4.3% to 46% by volume. Okay, and is H₂S soluble or not? Yes, it is soluble in water and other liquids. So those are the properties, and all these properties, we are going to see the implication of them as I proceed in this training. So having mentioned the properties of H₂S in a nutshell, personnel who may be exposed to H₂S should be aware of and understand the significance of these properties. Concentration of H₂S will be different at different locations. The toxic effects of a particular H₂S concentration may yield variable responses depending on the duration of exposure, level of concentration, the physical condition of the subject, and the frequency of exposure. So this thing that I just said in summary signifies the importance of the properties of H₂S. Like I said, in low concentration, It has a characteristic odor of rotten eggs. In concentrations over 100 ppm, that is 100 parts per million, the human sense of smell quickly paralyzed. So you cannot smell the H₂S again when the concentration becomes above 100 ppm. Therefore, the sense of smell cannot be relied upon to detect H₂S, and the swearing or availability of respiratory protection is extremely important. So at this concentration, it is very, very mandatory that any personnel that is going to work in an H₂S detected area must wear a respiratory protection. Okay. Now, H₂S is also said to be heavier than air, having a vapor density of 1.189 with respect to the air. Okay. Therefore, higher concentration can be found at low-lying areas such as arches, cellar trenches, and other natural topographically low spots as it migrates. However, the gas is completely miscible with air. So the H₂S, because it is heavier than air, it tends to, go down. It can also be found in low-lying areas. So that is why whenever H₂S is released or there is alarm that there is H₂S released somewhere, the personnel are, required to go upwind. So that is, I'm going to talk about the wind socks to detect the direction of the wind. So once you know the direction of the wind and there's release of H₂S, then you go upwind. Since we've got to know through the properties of H₂S that one, it is colorless, it is odorless, and it is heavier than air. How do we now detect if there is H₂S? Okay, so what are the detection methods? How do we detect H₂S? We cannot detect by sense of smelling, it's not reliable. Although at low concentration, you can hear the distinctive rotten egg smell. But when the concentration goes above 100 ppm, as I mentioned earlier on, the sense of smell is deadened, is paralyzed. The olfactory lobe is affected, you cannot smell again. Then in that situation, what do you use to detect the release of H₂S? I will tell you. So the three different types of H₂S monitors used in classified areas, okay, we have the three types. We call them H₂S monitors. We have three types. We have the personal, the portable, and the fixed monitors. So personal monitors or portable monitors must be used to test the atmosphere. So first of all, any area that is suspected, when you suspect that in this particular area there might be likelihood of release of H₂S, so before any personnel will go to that area to work, it is mandatory that a test must be carried out. And the personnel who has the training must go there with his own full PPE, the face mask, the SCBA, and all the necessary personal protective equipment to go and make the test. And he or she must not go alone. Okay, so the personal monitors or portable monitors must be used to test the atmosphere first, where the concentration of H₂S gas in the atmosphere can exceed 10 ppm. So this 10 ppm is the threshold limit value of
of H₂S that is allowed for workers to work for 8 hours. Now we have the personal monitors. Personal monitors must be worn at all times. Whenever you are working in any environment where the concentration of H₂S is more than 10 ppm, all the personnel must wear personal H₂S monitors. Okay, then a variety of monitors are available, which can be worn by one person, usually attached to the clothing. Okay, monitors are to be worn chest high. You put it chest high. Chest high means close to your breathing area, close to your nose, so maybe to your breast pocket or to your collar or something like that. So in short, it must be attached to the chest, the high part of the chest, near the breathing zone. So the monitor is to show an alarm when you have more than 10 ppm of the gas. So the second type of monitors for H₂S is portable monitors. The portable monitors can be placed in a work area to continuously sample the environment for H₂S gas. These monitors are set to alarm at 10 ppm. So once the level of H₂S is 10 ppm or more, or a little more, the alarm will start. That is the programming. The alarm will just start. So once you hear the alarm, you should know that definitely the H₂S concentration is already more than 10 ppm. So regardless of the detection type used, all work that might involve the exposure of personnel to H₂S must be supervised closely by qualified personnel. The third one among the H₂S monitor is the fixed monitoring devices. The fixed monitoring devices. So the fixed point gas detection system are used in a variety of ways to protect workers and assets. One application in which they are used is to monitor gas release as part of an industrial process. So processed gases can be released from a number of different areas, such as valves, weld joints, seals, flanges, or gaskets. So shipping or storage areas should also be considered as release points as well. So you have to put these fixed monitoring devices. You have to install them in all those areas. Like processed gas can be released where number of different like valves, like weld joints, like seals, like flanges, okay, or gaskets. I've participated in one project before in the Kuwait National Petroleum Corporation, whereby we fixed this type of monitors. Okay, and when we are doing the work, when we are fixing the fixed monitors, we are also with our own mobile or portable monitors that are fixed to our breathing zones.
The next thing I will be talking about is the health effects of H₂S. Under the health effect of H₂S, I'll be telling you the concentration in relation to the exposure time and the health effect. Okay, so let me start with 0.1 to 10 ppm. When you have 0.1 to 10 ppm of H₂S being released, instantly you will have the odor. You will be able to detect the distinct rotten egg odor. Okay, the maximum continuous exposure time for 10 ppm is 8 hours. So that is the threshold limit value of H₂S. That is very important to note. Now, going forward, from 10 to 100 ppm, when you have like 0.0 percentage, then the exposure time is about 30 to 60 minutes. So in that state, in that concentration, you will have eye and respiratory tract irritation. You have the sense of smell becoming dull. You will have a burning sensation in the eye or in the throat. And the respiratory protective equipment must be worn if exposure should be continuous. That is, with this amount of 10 to 100 ppm, if you are going to continue to remain in that work environment or in that environment where the H₂S is being released, okay, if you are going to remain there for more than 60 minutes, then you will need respiratory protective equipment. Otherwise, you have to leave that environment immediately. Now, if you have more than 100 ppm, let's say you have between 100 and 200 ppm, okay, this is divided into two parts. The first part, the exposure time from 2 minutes to 15 minutes. In that time, in that period, there will be loss of sense of smell. The olfactory lobe will be attacked and you will not be able to smell anything again. So, and that is the more reason why we say that sense of smell is not a good detector of H₂S. You cannot rely on your sense of smell to detect the presence of H₂S, because at a point, if the release continue and you did not go away from that area, that same H₂S is going to attack your olfactory lobe and you will lose your sense of smell. And once you lose your sense of smell, you might be deceived that probably maybe the gas is no longer available. It is still there. Yes. So when you remain there for more than 8 hours, between 8 to 48 hours, the next thing is going to be death. The next effect on your health is death. It's as simple as that. Okay? And if you have more than 500, between 500 and 600, you are exposed within 30 to 60 minutes, the first health effect that you have is the central nervous system. The central nervous system will be affected. There will be confusion and loss of balance. The person will feel confused and he will be staggering. He will not have stability. He will lose his sense of, there will be loss of balance, in short. Then, if you have more than 600, let's say between 600 to 1,500 ppm, okay, you can only be exposed, let's say such person is exposed to that amount for 2 to 15 minutes. The next thing, apart from the central nervous system being affected, apart from confusion and loss of balance, apart from the loss of odor, okay, the H₂S odor can no longer be detected. Then the next thing is that the person, if continuously stay there for the next 1 hour, the person is going to die. So rapid loss of consciousness, respiratory paralysis, followed by what? Followed by death. So that is when you have between 600 to 1,500 parts per million of H₂S. Now, let's say in a location we now have about 2,000 ppm. What is going to happen? Instantly, immediate loss of consciousness. The person will lose conscious, it will become unconscious immediately. Then there will be rapid failure in breathing. The person will lose his breathing and the heart function, followed by death. So this type of situation, we call it IDHL, that is immediately dangerous to health and life. Any situation that is going to lead to immediate fatality, that is how we describe it in the field of safety. We call it IDHL, immediately dangerous to health and life. So, and that is the reason why we said that H₂S is one of the most dangerous gas in the petroleum industry. After talking about the health effect of exposure to H₂S, the next I will be talking about is the personnel protection against H₂S exposure. So working in H₂S area, how is the personnel going to be protected against H₂S? The first one is that all workers must receive a site-specific orientation and know what the alarms are and where the evacuation points are located in case of an emergency. So there should be a contingency plan before anybody can work in an area that is suspected to get release of H₂S. Secondly, all non-routine work must have a work permit and a pre-job discussion that identifies the risk of H₂S. What do we mean by this? There is something we call work permit system, whereby before you can work in an area in the oil and gas or in the refinery, maybe in the petroleum industry, maybe in a refinery, you must first of all get a work permit. We have different type of work permits. You have cold, hot, confined space, like that. So you must get the appropriate work permit then before you can. And when you are applying for the work permit, okay, you will specify the area and the operator of that area, if it is a likely area that H₂S can be released. So they have to first of all check. Okay, so portable gas monitor must be used to test the atmosphere whenever there is a possibility of a release of H₂S gas. So they will use portable gas monitor to check the atmosphere of that area. Okay, so if H₂S is detected, depending on the amount, then they will make recommendation for the appropriate PPE to be used. Then workers must wear the SCBA. The SCBA, I'm still going to talk about it in details, but the SCBA means the self-contained breathing apparatus. So they have to wear that when testing the atmosphere with a portable gas detector when it is known that there will be H₂S in the atmosphere. Okay, and when working in a confined space that contains H₂S, there must always be one more SCBA available than the crew members. So, for example, if you have a 3-man crew, then you will require 4 SCBA. Okay, then workers must know where to locate the wing socks. The wing socks is what is installed in the area that will detect the direction of the wind. Okay, you will, through the wind socks, you can know the direction of the wind. So in case of release of H₂S, the personnel must move upwind. Okay, so in the case of an unplanned release of H₂S, the personnel must move upwind. And how would they know? By the wind socks. Some people, they use sand. They will carry the sand and drop it like that so that you will know the direction. But that one is not all that reliable, because suppose the wind is not blowing at that moment, It's not blowing strongly to, to blow the sand, but the wind socks can always indicate and show to you where is the direction of the wind. So in case of emergency release, then you have to know that we have to move upwind. So all operators working in an H₂S area should wear personal H₂S monitor. Apart from probably maybe there are fixed ones, you must carry your own personal H₂S monitor anytime you are working in an area that is that is likelihood of release of H₂S. If there is an unplanned release of H₂S into the atmosphere, all workers in the area must do what? They must evacuate without delay. They must evacuate immediately. And when they evacuate, they will go to the evacuation point, or what we call assembly point. So communication must be made to the control room to sound the alarm. So the supervisor of the team must immediately call the control room, then they will release the alarm so that everybody in that area will move to the evacuation point. And before that time, there must have been drills about how to go about escaping when there is emergency release or an unexpected release of H₂S. So in the event that a worker is overcome by H₂S, he must be moved to fresh air as soon as possible. But remember to protect yourself first. That is the principle. If you want to go and rescue somebody, you must also make sure you put on the appropriate mask and the breathing apparatus, and carry one extra that you are going to use to rescue the victim. Now, in case a personnel is being knocked down by H₂S, what are the necessary procedure to follow? The first thing to do is to evacuate the area immediately. Move upwind or to a higher location. Why are we moving to higher location? Because as mentioned previously, when we are talking about the properties of H₂S, we said H₂S is heavier than air. It has more density than air. So it tends to go down. Okay? So you move upwind or you move to higher location to escape. The second thing is call the control room. So during the training, everybody that will be working in the area that is likely to get H₂S release must have received the training, must have been given the number of the control room to be called, especially the supervisor in charge must have the number to be called, okay, and let them know where you are. So you call the control room to inform them the situation. Then you have to assess the situation, consider other hazards. Mask up. You must wear the SCBA before performing the rescue. Okay, the rescue team will come now, then protect yourself first. If you are not trained as a rescuer, if you don't know anything on how to rescue, don't just try it. Don't try it. Don't be moved by emotion. Maybe the person that was knocked down is your friend or your brother or your family. Don't think twice. Don't try. Except if you have been trained as a rescuer and you have a spare SCBA, apart from the one that you are wearing by yourself. Then you can remove the victim to a safe area, upwind, and with enough room to perform the CPR. That will be the next thing. After moving the victim to the safe area, the next thing you are going to do is that if the victim is unconscious, then you begin the artificial respiratory on the victim. That is the CPR. Okay. Then report and assure the victim is transported to a medical facility. So after reviving him, after you must have performed the CPR and the person gained back his consciousness, then the next thing is to move such person immediately to a medical facility for further medical attention. Because of the high risk and danger that comes with H₂S, it is highly important and essential to have protection of the personnel that will be working in an area suspected the likeliness of release of H₂S. And the most important prevention or protection against H₂S is the breathing apparatus. So the breathing apparatus should be available on the site in sufficient quantity. So if you have 3 people working, you must have minimum of 4 breathing apparatus. And all the breathing apparatus must be in good condition. It must have been checked to ensure that it is not damaged, it is reliable, because it's going to save life. So the SCBA is used and must be used only in the pressure demand mode. That is, it must be positive pressure. It must disallow the ingress of contaminated air from outside. And the facial hair, the bears, must not be there to enable the seal between the respirator and face piece to be well fitted. Okay? And no person should be allowed to enter any environment or working area where it is suspected that there will be high concentration of H₂S. Any concentration of H₂S that is going to be more than 10 ppm, nobody should enter such area without a proper respiratory protective equipment. Hydrogen sulfide is soluble in water as well as on moist mucous membranes. So all hydrogen sulfide respiratory protective equipment should therefore be equipped with full face mask. It is very important for me to talk more about protection from H₂S. And for protection from H₂S, fit testing of respiratory protection equipment is necessary for personnel who may be exposed to H₂S. Fit testing will ensure that a good seal can be maintained between the wearer's face and the mask. This is very important. Now, any work area where H₂S may be present must be approached from the upwind, if possible. There is emphasis on this upwind. I have talked about the wind socks. Wind socks is very important to determine the direction of the wind. And once the direction of the wind is being detected, then you must approach the work area from upwind always. This is very important. Why? Because H₂S is what? That is why we talked about the properties of H₂S. So because H₂S is heavier than air. Now, when working in a potentially hazardous H₂S environment, there should be quick and easy access to protective equipment, ideally. A mask or breathing apparatus should not be more than 1 breath away, which must be stored upwind of the work. Upwind. You must store the breathing apparatus upwind. When you realize that there is release of H₂S, you must move upwind. There is an emphasis on upwind and the availability of breathing apparatus, because H₂S is very, very dangerous. Okay? Now, in atmospheres which contain more than 10 ppm of H₂S, such as inside tanks, arches, cellars, vessels, and other confined spaces or open space, only the two following can be used. I will mention them now. I've mentioned them before, but I want to lay emphasis on the two respiratory equipment. The first among the respiratory protective equipment is self-contained breathing apparatus, SCBA. This is most suitable where more freedom of movement is required, but the time of use is limited to only 15 to 30 minutes. It is better to choose an SCBA of positive pressure. So the positive pressure will enable the face mask to be tight fit, and it will not take air from outside, but it will only be like releasing air to the outside. So it will be fitted, it will not take air from outside. That is what is meant by positive pressure type, to prevent ingress of contaminated atmosphere at the face seal. And you remember, no beer. Okay? These have a reservoir of breathing air in a cylinder carried on the back, which under normal use should supply 30 minutes of air. These have an NPF of 2000. So may be used in an atmosphere of up to 10,000 ppm hydrogen sulfide in here. When I was talking about the properties of H₂S, and when I was talking about the health effect of H₂S, I made mention that when you have 2000 ppm, that is instant, when you are exposed to 2000 ppm of H₂S, it will lead to instant fatality, instant death. Okay, but now we are talking about 10,000 ppm. So if there is 10,000 ppm of H₂S in the atmosphere, but you are secured with a self-contained breathing apparatus, okay, you are saved. But this SCBA, you can use it between 15 to 30 minutes. That means when you carry the SCBA and you are in an environment of more than 2000 ppm of H₂S, what you should care about is not to stay. What you should care about is how to escape from that location. Okay? The second type is the supplied air breathing apparatus, SABA, with auxiliary self-contained air supply for emergency purposes. These systems consist of large air tanks with working mask and a small independent air cylinder as backup for self-rescue. Okay, that is the difference between the self-contained breathing apparatus and the supplied air breathing apparatus. For the self-contained breathing apparatus, there is a limit time that you can use it. Some are 15 minutes, some 20, some 30. Most of the time, maximum 30 minutes. But for the supplied air breathing apparatus, you can use it for longer time. They can be stored on a wheeled cart and moved to where they will be needed. So they have an NPF of 2000. They should be of a positive pressure type also. This is very, very important. Okay, and when we say, then another thing of note is that you should not use escape mask. Under no circumstances you should use escape mask like a gas mask devices for working in a strictly forbidden or where H₂S is can be released, because the escape air, you can only use it. There is no cylinder carrying any air that will supply air to you. So when you are using gas mask, you are still breathing. You will still be breathing the environment air. So that is dangerous. Don't use it. Then the breathing air must be deep breathing air or a mixture of medical oxygen. Never use weather's oxygen, as this presents other additional hazards. Don't use weather oxygen. Okay? So these are the two major types of the respiratory protective equipment. The first one is the SCBA, the self-contained breathing apparatus, and the second one is the supplied air breathing apparatus, SABA. Another very important thing which I considered very paramount to talk about is the cleaning and maintenance of the breathing apparatus. I mean the respiratory protective equipment. Okay, all breathing air equipment should have monthly inspections. Okay, this inspection shall include: one, you have to check the pressure of the cylinder. It should be read full. It should be full. When you check it, the pressure of the cylinder should be full. Okay, then condition of breathing hose. The breathing hose, okay, you have to check it. See, there is a hose that is attached with the mask and the cylinder. So you have to check the condition that it does not cut, it's not leaking. Okay, then the condition of the mask is itself. The straps fully extended. So the strap that you are going to make it to become tight, it must be fully extended. Mask protected in a plastic bag. So you must always keep that mask in a plastic bag to prevent dust, accumulation of dust or anything like that. So then you have to assure all parts are clean and in good condition. You have to check it properly. This thing is an equipment that is going to save your life at the work site. So it is mandatory on you to take adequate care of such equipment. Such equipment is precious. You have to take care of them. Okay? So immediately after use, the SCBA shall be cleaned and stored. All parts shall be wiped down and left clean. So the first piece must be sanitized with a commercial disinfectant that is approved for use by the respirator manufacturer. So don't just use any kind of cleaner or sanitizer. Use the one that is approved by the manufacturer of that breathing air equipment. That is very, very important. Now, let me quickly talk about the corrosion effect. Hydrogen sulfide, H₂S, when it reacts with iron or steel, it will form iron sulfide, which in turn reacts with air to form iron oxide. Okay, so iron sulfide is pyrophoric iron. So the later exothermic reaction can generate sufficient heat to ignite flammable vapors. Okay, why are we concerned? We are concerned because of the likely reaction of the iron sulfide, which can generate sufficient heat and ignite flammable vapors. So where iron sulfide, which is a pyrophoric ion, is present or suspected to be present, what do? The entire surface should be kept wet with water during handling. Then the exposure to air should be minimized until the iron sulfide is buried or exposed in a controlled environment to allow the reaction to occur. So this is just for mentioning, this is just for mentioning, but it is very important because fire is also a serious hazard. Okay, so which we have to mitigate against. That is why I mentioned it. Yeah, so far I've been able to talk about the overview of HSE in the petroleum industry, and the second part of the topic I am treating, the H₂S, hazard of H₂S in the petroleum industry. So far I've been able to talk about the properties of H₂S. I've been able to talk about H₂S detection method and protective equipment. I've been able to talk about the health effects of H₂S exposure. Okay, then personnel protection against H₂S exposure. This I talked extensively about it, and I talked briefly about the corrosion effect. But equally important is the last thing I want to talk about now, which is the first aid. Because although our aim is to protect the people, to make people safe, okay? But in case whereby you make the training, you make the training, you make the detection, you make everything, and something still happen, there must still be something to do, and that is first aid. So it is very, very important. So if eyes becomes irritated while working in a plant or an area that has been determined to be safe from H₂S, the following precautions should be taken immediately. 1, you have to leave the area at once and move upwind. Move upwind. Okay, so the installation of windsocks is very, very important. Anywhere you think or feel that there might be release of H₂S, you have to install wind socks. These wind socks will help you to know the direction of the wind. Then it will enable you to know how to move upwind in case of H₂S release. Then, after moving upwind and moving away from the source of the H₂S, the next thing is to flush your eyes thoroughly with water, ordinary water. Flush it thoroughly. Then contact your supervisor. I told you the supervisor must always have the phone number of the control room. So from there will be further actions can be taken. So since the resource of exposure to H₂S is paralysis of the nerves controlling respiration, a person can quickly lose consciousness and stop breathing. So H₂S is very, very fatal. It is very, very dangerous. So that is where we have to be extremely careful and conscious of what we are doing in an H₂S suspected area. So if the victim is promptly moved to a safe area and artificial respiration is started immediately, okay, the chances of complete recovery are good. And delay in the use of artificial respiration will reduce the chances of recovery. However, it must be continued until normal breathing is resumed or until a medical professional can assume full responsibility for the patient or the rescuer is physically unable to continue. So if the rescuer is physically unable to continue, he must leave because your own safety first. Any person overcome by hydrogen sulfide must be treated for shock by keeping the body warm while artificial respiration is being applied and keeping the patient calm until it can be diagnosed and released by medical personnel. So we are now coming to the end of the safety talk with Adiat today. I hope you have learned one thing or the other, and I want you to share this video with your friends and loved ones. Like the video, and if you have not subscribed before, please endeavor to subscribe. Thank you, and God bless you. Keep safe always. Bye-bye. Love you.